Hello, everyone. Fine-tuning your applications for success. Tools and tips for performance testing. Good afternoon, everyone. Really excited to meet you all today. I want to talk about performance testing, why it's important, some of the tools you can use, and how some small fixes can lead to big successes. But first, who am I? I'm Amit Chauhan. I'm an Appian Enterprise Architect at Mastodon Technologies. I'm a certified lead developer who has been working in the Appian ecosystem since 2011. To put that into perspective, I was around before sites, portals, even records, or tempo was even a thing on the platform. So I've been around for a while. But finally, if you look me up on LinkedIn, I have the self-absorbed and conceited title of the strongest Avenger. And next to Appian, I really like talking about Pokemon. So after the talk, let's talk about your favorite Appian components or your favorite Pokemon. But let's get down to business. Before talking about why performance testing is important, let's go ahead and talk about maybe a little bit of what is performance testing. The way I like to explain it is talking about how your Appian application will run under varying scenarios and loads. Some of the factors to consider, how many concurrent users are hitting your system, how much data is currently loaded in your databases. And one of the primary goals of performance testing is to find and mitigate performance bottlenecks that could slow down your system while also looking ahead to the future. And when I say that, here are some questions to consider. Will your pretty dashboards load fast enough once the app is already in production for about, 3 to 6 months? Do you have enough hardware in your servers to handle all those users hitting the application years down the road when there's maybe hundreds of thousands of rows of data in the database? Food for thought. Now, some of you in this room might be thinking, well, Amit, we just did a UAT. We have automated fitness test scripts already running. Why do we need to do more testing? Well, consider this. A poor performing application in production, maybe combined with some mismanaged expectations, will lead to, and I'm going to see some bad words here, unhappy customers. Did I just send a shiver down your spines? If not, let me scare you a little more. So let me indulge you all in a haunted tale of crushing loads and production outages. So this was for our fintech clients. They were about to go live with an application that had been tested for about 1,000 concurrent users. The go live itself actually went really fine. The application was tested. There were many celebrations to be had. But lurking beneath all that sale code, however, dun dun dun, it turns out the actual number of users hitting production was upwards of 5,000 users. The app was not tested for that increased user activity. So as a result, production went down for a week. Let me say that again. Prod went down for a week. To say the users were unhappy, that is probably the understatement of the century. But fear not, I'm here to help you mitigate this nightmare. All right, enough scary talk, you are getting nervous. Let's actually talk about the meat of the matter, performance testing. It's important to do performance testing, not just for the expected go-live usage. You also want to do it for future users as well. The factors to consider, again, the number of concurrent users, the amount of data going around, heck, even the number of live applications in your system. All those factors can definitely change in the future. A common mistake that I've seen in all my years of experience is that performance testing is done in an environment that is very, very different from production. For example, there could be, half the memory, half the CPU cores. If you do testing in such an environment, you're probably going to find a lot of false positive findings and not truly be able to say that you simulated what will happen in production. So therefore, it is important when possible to do this sort of testing in an environment that mimics production. By the way, that quip I made earlier about UAT testing, that's not a substitute for performance testing. The kind of activity that's going on during then is likely not to be indicative of what goes on in production. Finally, performance testing is a bit of an effort, but it can have big payoffs. So it's great to prioritize and account for this sort of testing during your capacity planning, sprint planning, and if you're just starting a project, really great topic for sprint zeros. So I'm going to say this point a few times throughout the presentation, but catching issues early is key. Let me give you a less scary story. I already scared enough of you already. A workforce management application was performing poorly when there was some early performance testing done. Just with under 50 users, the app was almost unusable. However, because the testing was done proactively, it was a much easier time to spend the time optimizing the code and preparing it for go live. As a result, happy ending here, the app was able to go live and support over 1,000 concurrent users. See, I can tell happy stories for once. It's a great win. If you like these kinds of stories, stay tuned. I have another one for you all. But we've talked about the what, and we talked about the why. Let's do the how. How do you do performance testing? You're going to need quite the toolbox. You definitely need a tool that can simulate users hitting your system through carefully designed test cases. Does such software exist, you might ask? Well, happy to report, I know two of them. JMeter. It's a Java-based tool that you can use for simulating user load on web apps. It used to be just for web apps, but I think they've expanded sort of the use case. And then relatively new, there's Locus. This is more of a Python-based tool for programmatic load testing. I do know that Appian supports these two tools. You can find additional libraries on the app market. And personally, I have a lot of experience with JMeter, so I can say these tools definitely do the job. But that's just one half of the equation. What about data? You're going to need a lot of data, and I really do mean a lot of realistic looking but still synthetic data that conforms to your data model. You don't want to do it manually. You have better things to do, like sit here and listen to me talk for the next 20 minutes or so. So there are tools such as MockRoots and online synthetic data generator, and you can use it to generate the data for the tables that you need and then export it out as a CSV file that you can upload, or even as a SQL script that you can just run into your databases. I do know that Appian has a tool called the database load generation tool that connects directly to the tables in your database and automatically loads the data for you. So you also have that option as well. I just want to say, the reason I said you need realistic looking data, you want to be able to properly test features such as filtering, sorting, all of those tools. It doesn't really make sense to try and sort something that is just the number one everywhere. So up here on the screen, I have what's a kind of a report that you can get out of JMeter. I can see sort of the transactions that were executed, the number of times it was executed, and probably most importantly to you all, the average, minimum, and maximum execution times. Looking at this, I see, on average, everything's running about 3 to 4 seconds. If I had just run this testing and I wanted to do some analysis, I'd probably look at maybe the record list. I see that auditor task is taking a little bit of time. And a point I'll cover a little later, but I find in my experience that when you start fixing some of these issues, it kind of propagates across the application as a whole, and you see performance improvements across the board. So you have this test, you have this report, and now you're ready to do that deep dive. Find those pesky bottlenecks, figure out what's going wrong. You're going to need a lot of logs to go through this and a lot of investigation tools. Let's talk about them. So, right off the bat, designers in Appian, they can utilize what's known as the performance view. This gives you sort of a high-level idea of how your interfaces, your expression rules, and even your records, how are they doing? And this is a good time, this is a good spot, because then you can drill down to areas that seem to be performing slower and figure out, okay, maybe it's this expression rule that's causing the problem. Maybe there's this query that's causing a lot of problems. Why is this local variable take so long to load? Questions and answers. For cloud environment customers, I do also recommend having up the Appian Cloud resources. It's a good idea to monitor the testing environment, see how the CPU, memory, all those key hardware factors, how are they holding up when you're running your performance testing. For on-prem customers, use your favorite hardware monitoring tool, such as Logic Monitor and other necessary tools. But that is just the beginning. Over my career, I've looked at many logs when trying to debug issues. And some of the ones I've used a lot include the RDBMS performance monitoring logs. These ones are particularly good because they contain what's known as the preparation, execution, and transformation times for your queries. What do those times mean? Well, let's say a view is taking very long to, execute. I wonder what time that stands for. Execution time. Maybe you have queries that are returning abnormally large amounts of data, and it takes a while to transform those data into the CDTs. Transformation time. You also have the expression details log file. This can give you a holistic view of how all the expression rules are doing, figure out which ones might be running a lot slower than expected. Finally, there's also what's known as the system.csv log and even the engine logs. Looking at those can give you an idea of how the hardware itself is running. So for example, one I commonly look at, the system.csv log, that has a metric known as the load average, and that's the number of, I believe, running CPU processes. So if that one runs abnormally high, maybe you need more CPU cores in your server. Food for thought. Finally, for all the database fans in the audience, we have the explain plan. This is really useful to put the explain keyword in front of the select query and analyze how the RDBMS optimizer is going to run your queries and where indexes are being used or potentially not used, and where maybe a subquery might be really problematic. So, for example, up here, I have a couple of join statements here against tables known as pairing, beverage, and cheese. Hopefully I get to play around with that at the dinner later today. But no. I can see here that in that fourth column, type, it says all. It's scanning all the rows. And I know this because there are no indexes currently being utilized. There were no indexes set up on the columns that are being joined on. So right away, I can think, okay, maybe I need to put my indexes in. And I'll cover some of the performance benefits of doing this a little later, but I will say that by adding indexes just to those columns, the performance time went from 0.045 to 0.0005. I think that's the right number of zeros. So just simple fixes like that can make big improvements, and we'll cover that a little later. I should have done performance testing for my presentation. So I've talked a big game about the performance testing and why it's useful. Let me give you all perhaps a more in-depth success story where performance testing was a key part of our sprint cadence and how that led to project success. This was for a data analytics company. They were looking to use Appian to modernize their audit review workflow. One of the key metrics I recall was that they anticipated their auditors would review about 100 claims a day. And the client wanted to start off with a pilot go live before increasing the user load, and they expected it would be a pretty moderate growth there. So sort of the opposite of what's known as like a big bang approach. So the team and I got to work on establishing what's known as service level agreements, or SLAs, and sort of the expected times that the client wanted the workflows and tasks, how long they would take. In some cases, it wasn't always a hard number. Sometimes it was more of a range, especially because this was a brand new workflow. They were still trying to figure out all the necessary flows. But I want to emphasize that by taking the time to get these times, you can then incorporate that into your test scripts. When you're designing these scripts in JMeter, and I believe also in Locus, you have to incorporate what's known as think time. You need to be able to simulate a user, looking at a form, thinking, what should I put here? What should I select? Because otherwise, you're just going to have the test just rapid fire click through everything. And unless you're me and super hyped up on caffeine, that's not really a realistic test of what goes on in production. But back to the story. The client had a good idea of what the future load and future usage would look like. So given that information, the team and I decided, let's start from a small baseline, like a small threshold, established as our baseline. Then each iteration of the test will increase the number of users, perhaps load more data into the database prior, and see how the system sort of handles it. This diagram of up here is sort of a way to visualize the cadence of the testing we did. So initially, we obviously discussed the scenarios with the client, came up with those SLAs. We then set up the tests and users in JMeter. We then used Makaru for loading all the claim data and all the other test data into the databases. And then we ran the tests against that small baseline load that I was talking about earlier. So this gave us a good threshold of like, okay, at minimum, we think the system will run here. It's a good comparison point. Then as I mentioned earlier, we then reran the test, but this time with increasing number of users, increasing amounts of data. Once all those tests were done, we then decided, all right, let's aggregate all this data into a useful report. Let's analyze it using the logs that I was talking about earlier, and then work with the product owner to triage those issues based on priority. Then after a sprint or two of development, we would rerun the tests and compare the data and see how things were running. I'm going to spoil things right away and say that this was actually a great success. One of the key things that came out of that was we were able to go to the client with very clear expectations on, we expect the hardware of the environment and the way the system is built now, it will run with X number of users, X amount of claims in the system. And something I thought was really cool was that the client took the results of the JMeter testing that we did and presented it to their leadership to say, hey, we think that in 3 years, we might need more CPU, more memory, and based on these test results, we should get X more memory, X more hardware and all that. So I thought that was really cool. To state the obvious, we were proactively doing this testing. We were able to find the issues early, and I'll talk about those in a few minutes, and really sort of set that trust and good expectations with the client. And then finally, a little bit of a bragging point I've always carried with me was that the client themselves wished that other application teams, just in general, followed this sort of paradigm when it came to doing performance testing. So lots of wins all around. Okay, so I know much of you are waiting to hear. What's the secret to really having performant apps? Let's cover some of the what I call the low-hanging fruit issues. So indexes. I briefly talked about this with the beverage pairing cheese example. I can't remember my own lines now. And in this case, what was going on was that we were querying many of the tables and views with a column that wasn't indexed. It wasn't the primary key. It was a different column entirely. And we thought, well, if that's the important column, let's put an index on there. Makes total sense. And just adding that index alone improved many queries across the board, from 200 milliseconds to less than 10 milliseconds. I know that still sounds good because it's still both numbers under 1 second, but as more transactions happen, more data, more users, even small performance bumps can add up over time. Batch sizes. I am so guilty of this one. When I'm quickly designing an app, want to get a prototype up and running, I'll just slap -1 for the batch size and move on with my day. We don't want to necessarily do that. That's returning all the data that's in the database. And if you have hundreds of thousands of rows of data, you will most likely slow down your report, or worse, crash it. So, working with the client, we were able to identify more reasonable batch sizes for these queries. And if we had to return a lot more data, we were possible to set up pagination on grids and whatnot to minimize the load on the interfaces. Finally, views. This one's technically a bigger example than the other ones, but I thought it's a good one to still talk about. So we had a couple core views in the system, and they were really slow because we were doing a lot of intensive calculations in the view. Particularly, I think we were doing calculations on dates, like number of days between certain actions and other sort of calculations. And we didn't have materialized views to take advantage of. So as a result, every time we called the view, it was rerunning those calculations. It took forever to do those date calculations. So what did we do? We decided we know we only need these calculations about once a day. So let's set up a stored procedure and a nightly process that we can then run the calculations on and push that data to a column in a table. In some cases, we use database triggers to also do some of these calculations and output that data to a column. The end result there was that once we redesigned the views a little bit, the views simply just had to retrieve the calculated values from the tables instead of having to do the calculations itself. So over the years, I've kept these sort of metrics with me because I like talking about this topic in case you couldn't tell. And just by those changes alone, indexes, batch size, modifying a view, we were able to essentially change the average time by about a little over 2 seconds, from 5.3 to 3.275. And I want to emphasize, it was just making changes like this, adding indexes where we forgot to add indexes, reducing the batch sizes in certain queries, and fixing the views that powered our record lists and whatnot. So the takeaway I want you all to get from that is that sometimes seemingly small fixes can really add up and improve your system. So, in conclusion, I'm going to pretend to be my heroic alter ego, affectionately dubbed Professor Thor. I hope you like that one, Stacy. And just summarize that performance bugs can crop up on day one of go live or 1 year after go live. And it's important to work with the client on proactively conducting performance testing early and often. And to repeat that point again, seemingly small fixes can have major impacts. Appian itself has many logs to help you in your investigation. And I was just talking about earlier, tools such as JMeter, Appian has ways of supporting that kind of testing as well. You all have the tools and hopefully now knowledge necessary to prevent performance nightmares, as my heroic alter ego would say with his glowing golden hair back when I was young and heroic. But no, thank you all so much for attending. I do hope my presentation today was helpful. To learn more about what's been talked about today, or just all things Appian development, visit the Appian Academy, or visit those Ask an Expert stations in the Cherry Blossom ballrooms. Finally, and most importantly, QR code up there. Please take the session survey. Your feedback would be most appreciated. And with that, let's go ahead and do some Q&A. And there are people around with mics, so definitely raise your hand and they'll bring one to you.
Yeah, I have a question. Nice to meet you, and thanks for doing a Q&A.
Nice to meet you too.
I'm Jason. I work for the Army. We're a new Appian customer, and I just found out today that Appian does have a Kubernetes containerized runtime. So we're probably going to go in that direction versus building Linux VMs. We have a high security environment, so we have to self-host.
All familiar with that? Yep.
Yeah. So my question is, how does moving to containers affect performance bottlenecks and issues with Appian? Because I've heard some things before about slowness due to VM sizing and constraints on memory and processors. So just if you have any feedback on that.
From my limited experience, I would say the issues that you brought up, improperly sized VMs, perhaps maybe not having enough memory allocated for those VMs can definitely play a factor. And honestly, that's why performance testing proactively is a good thing, because then you can load up an environment when you do your testing for, okay, well, our memory usage just keeps spiking. Perhaps this is a consideration to up the production VM with more hardware and whatnot. Truthfully, I haven't used VMs as much, but from my limited experience, I've seen those kinds of topics come up. Thank you. Good question. Anyone else? I really scared you all with that story earlier, didn't I? I'm just the harbinger of bad news. Yes.
Hey, thank you. So my question was around the performance testing or performance the data fabric bring. So you have logs for the queries and
Mhm.
RDBMS. So how do you performance test or fine tune the data fabric, or what's the performance of retrieving the data, or
Good
whether
question. I'm actually going to go back a few slides because I recently found this out. So there are logs related to records that you can also look at. They, I believe, have similar metrics to the RDBMS ones, like execution time, preparation time, all of that. And then you can consider, perhaps, am I syncing too much data? There is the 4 million, at least as of now, 4 million row limit. Perhaps you're maybe bringing over too many fields, too many custom fields. So there are ways you can sort of monitor the performance of the records as well.
sorry, a follow-up question just
Yeah.
came in is, if I'm querying a record type in my local variables, right? Is it needed to have it in a local variable and query it once, or I can actually query it within my expression rule, because it's any which way is getting it from the in memory, right? So do you prefer querying the record type in the local variable and then using it within the process, or you actually query it wherever you need a specific set of data from that record type?
Good question. Just thinking on this. Generally, in just general with data, I like doing the query once and avoid having to repeatedly query. That said, with records and especially the synced records, there is the performance gain from having all that data available on disk. So there could be scenarios where it makes sense where that's not really a big concern, but that kind of goes back to doing the performance testing ahead of time and sort of gauging, okay, by repeatedly calling the record query, is my system taking a really big hit? Good questions. Anyone else?
Is there like a simple list on like the community site or something for general Appian specific performance tips you should look out for? Because like things like the database are pretty platform agnostic, but like I'm thinking in my own experience, random things like I had an Appian person look at my process model and they're like, oh, it'll be faster if you use the start process node instead of a sub process. And I'm like, why? And he was like, I don't know, it just is. So I'd love to know if there's like random Appian specific quirks.
Trust
that
me,
we're
I'm an
supposed to
expert. That's what
Yeah.
I go with. Now. There are a lot of good. I've seen a lot of good articles on Appian community, especially like for the process model example. I've seen articles about like making modular, smaller processes, ways you can reduce the memory footprint of the processes. I can't remember the articles right now, but I do know Appian has sort of various sort of success articles or methodologies that you can look up and get guidance on.
Okay, thank you.
Great questions. Have about 30-ish seconds. Anyone else have anything? Going once up. Mm-hmm.
Is there something like that for the data fabric?
To my knowledge, no. I think No, as far as I know, I don't think there's a specific index you can add to your data fabric. As far as I know, outside of if you're syncing from a table, those tables have indexes. And I think we're at time. Thank you all so much for attending today's talk. I really appreciate it.